Throughout our lives, we all have to face questions. They guide us, inspire us, and drive us forward. One of these questions is, how does a refrigerator work? Well, Elsie and I are here to answer that, so you can all go back to being able to sleep at night. A refrigerator works in mysterious ways. However, there are 5 main components. These are a fluid refrigerant, a compressor, the condenser coils, the evaporator coils, and an expansion device. The condenser coils are outside of the fridge, while the evaporator coils are on the inside of the fridge. Refrigerators work in a similar way to when you use rubbing alcohol on your skin. As we all know, rubbing alcohol evaporates at room temperature the way water evaporates at a low temperature in an oven. As it evaporates, it absorbs the heat of your skin, so you feel cold. Much like alcohol, a special cooling agent called refrigerant does something similar. Except in the refrigerator, the coolant is trapped inside coils that run through the refrigerator. As the refrigerant runs through these coils, it changes quickly from a gas to a liquid and back and forth. This chemical change absorbs heat. Usually, the refrigerant is pure ammonia, which is kept at negative 27 degrees Fahrenheit. Sidebar, ammonia is extremely poisonous, and if your refrigerator leaks it, it'll be very dangerous for you. To keep the refrigerator cool, the compressed gas heats up as it gains pressure. On the back of the refrigerator, the coils are used to let the ammonia gas release its heat so that it can condense back into liquid form. The now highly pressurized liquid form flows through the expansion device, which is basically just a small hole. On the one side of the hole is a low-pressure area where the compressor is sucking gas out. On the other side is a high-pressure ammonia liquid. The cold ammonia is sucked up and through the compressor where it is able to cool and refrigerate the refrigerator. The coefficient of performance is a term used to describe the ratio of heat that's being transferred from the cold reservoir to the amount of work that is supplied to make the change happen. It uses the formula coefficient of performance, or COP, equals QC, which is the heat transfer, divided by W, which is the work. Here is an example problem to find the COP of a refrigerator. If we are told that the heat transfer is equal to 4,500 joules, and the work put into that transfer is equal to 1,500 joules, by using our equation of COP equals QC over W, we will find that the coefficient of performance for that refrigerator is 3. A typical refrigerator has a coefficient of performance between 2 and 6, so we know that this number is accurate. Another type of rating that a coefficient of performance may have is called the energy efficiency rating, and the equation used for that is the energy efficiency rating, or EER, is equal to QC, which is the heat transfer, over T1, divided by work over T2, where T1 is in hours and T2 is in seconds. However, to make it easier for the common consumer and purchaser of refrigerators, many countries, including the US, just use a ranking system out of 5 stars. A higher rating means that the fridge is cheaper to operate, but likely more expensive to purchase. To summarize, here is how a refrigerator works. The compressor restricts the refrigerant, which is ammonia, as vapor, which makes it raise its pressure and drives into the coils, which are on the outside of the refrigerator. When the hot gas in the coils comes into contact with the cooler air temperature of the kitchen, it stops being a gas and becomes a liquid. Now, in liquid form at high pressure, the ammonia cools down as it streams into the coils inside the refrigerator. The refrigerant absorbs the heat inside the fridge, cooling down the air and making the refrigerator cold. Lastly, the ammonia evaporates to a gas, then flows back to the compressor where the cycle starts all over again.